Right, I've got a parametric question from the Pure 4 paper, the International Pure 4. This is a new specification, October 2020. Question 4. We've got a figure 2, sketch of the part of the curve with these parametric equations. The x value is 2t squared minus 6t. The y is t cubed minus 4t. So the curve cuts the x-axis at the origin and the points A and B. I'm going to find the coordinates of A and show that B has got coordinates 20, 0. We want the tangent to the curve at B, and then we're going to find out where the tangent hits the curve again. So there's going to be a tangent at B, and it's going to hit the point P up here somewhere, and we're going to find out where that is. Right, first of all, I'm going to find out where A, O, and B are. Now, we know at A, O, and B, the y value is 0, so I can put t cubed minus 4t equal to 0. If I factorise that, take a t out, and the other factors are t minus 2 and t plus 2, because I have t squared minus 4, which means the three t values are 0, 2, and minus 2. Because when you put 0 into here, you get 0. That's the 0 t at the origin. So A and B are when t is 2 and t is minus 2. So if you put 2 into the x, you get minus 4. 2 lots of 2 squared minus 12 gives you minus 4. So this is the A here is where t is equal to 2 and the x is minus 4. And when you put minus 2, you get x is 20. 2 lots of minus 2 squared, and then it'll be plus 12. So that's the A, O, and B. Then it says the equation of the tangent. Right, so we need the gradient of the curve, the dy by dx. So we differentiate the y in terms of t and the x in terms of t and divide them. So if I differentiate the y, I get 3t squared minus 4. I differentiate the x, I get 4t minus 6. And if it's at b, the t value there was minus 2. So we'll put minus 2 into here for t, and that will give me the gradient. This top line is 8, and that gives you minus 40 on the bottom. That cancels down to minus 4 over 7. So that's the gradient of the curve. At B, of course, the x value is 20 and the y value is 0. So y minus 0 is minus 4/7, x minus 20. Put in so the y one, if you like, is 0 and the x one is 20. Multiply by 7 and multiply that bracket by minus 4. I have 7y is minus 4x plus 80, and then just write it out in the form they wanted it, like that. And then it said, find these nouns with x coordinate p. Remember, p was where the tangent hit the curve again. So the easy way to do this, the best way to do this, is to replace the y with parametrics. So the y is t cubed minus 4t, 7 lots of that, 4 lots of the x parametric equation, minus 80 equals 0. If I simplify that, I've got 7t cubed, I've got 8t squared, I end up with 52t, minus 8 equals 0. Looks a bit unpleasant, but in your calculator will solve it. But we do know that there's a solution here of t is equal to minus 2, which means I can take t plus 2 out as a factor. Actually, it's a double solution because there's a tangent. So if you like, there's t is minus 2 there twice because it just touches it. But if I take t plus 2 as a factor, I'll need a 7t squared to get the 7t cubed. I'll need a minus 40 to get 2 lots of minus 40 gives you the minus 80. And that middle term, because I've got 14t squared here, and I only want 8t squared, I need this to make minus 6t squared. So that's got to be minus 6t. I could check it with the t component as well. I've got 2 lots of minus 6 there, minus 12, and minus 40 lots of t with these two terms. Like I say, I know that it's a double root here. T is minus 2 twice, so I know there's going to be a t minus 2 as a factor in this. and then 70 minus 20 is going to be the other factor. So just here, the t value is going to be 20 over 7. So just here, where it meets again, it's going to be 20 over 7, the value of t. Sticking that into the x parametric, we get minus 40 over 49. 2 lots of 20 over 7 squared, take away 6 lots of 20 over 7 gives you minus 40 over 49. And there we go.